Good day, M2. This is Teacher Win, and we are now in your last unit of your science book. So for this video, we are going to talk first about the layers of the Earth. For more information about this topic, so you can read pages 91 to 93 of your science book. So we know already about Earth, right? So Earth is a special planet of our solar system because of the 8 planets. So only Earth is a place or a planet wherein life exists, meaning plants, animals, humans grow and reproduce. So for this video, so let's try to identify what are our objectives. Number one, so we are going to describe the structure of the Earth's interior, meaning we are going to look at the Earth inside. Number two, we're going to study about the structure of the Earth's interior to plate tectonics. So plate tectonics are big pieces of land that is responsible for earthquake if they move. And also, so we are going to explain about convection that powers the plate movement. So let me ask you first this question. So how are layers of the earth different from one another? So you can pause this video to think of the answer before going to the next slide. If you're going to look at Earth from above or from the place that you are in right now, so you can just see trees, flowers, animals, people moving around, right? So you will just say everything looks simple. However, if we are going to dig deeper or what's beneath under us, so you will be surprised that Earth has several layers. So you can have here from the picture, so we can see here we have the crust. We also have here the different layers, your asthenosphere, lithosphere, mesosphere, and so many layers that is under Earth. So fortunately, we are going only to talk about the three main layers of the Earth. We have your crust, mantle, core, core. So again, so we are going to focus only with these three layers. If you talk about layers, so what comes into your mind? So basically, layers are just division or a slice or a section that divides a part. So if it's compare Earth to a layer of cake, so we can see here that your crust is similar to your icing. That sweet texture that is placed on top of your cake to make it beautiful and taste sweet. However, if we remove the icing, so we can see here different layers or different colors of your cake. So like for example, we have here your red velvet cake, which is like your mantle. And then we also have here your another layer of cake, which is your yellow cake, which is or comparable to your outer core. And then you also have here your layer of your cake, which is your white cake, which is comparable to your inner core. So at this moment, so we cannot just dig the land and we'll be able to see the layers of the earth, right? So that's why we are using cake to compare the layers of the earth. So let's begin first on the first layer, which is your crust. So on your crust, so we can see the oceans. So you can see the fish swimming there, or planktons or algae that are living there, or any animal or sea creatures that is living in the ocean. As well, you have here the land. So basically, your crust is where you can find the bodies of water and the landforms. That is where you find your trees, your houses, your buildings, and your cars moving around. And then underneath the earth, or shall we say underneath the ocean, is we have this so-called your oceanic crust. it is named oceanic crust because this is a piece of land that is located in the ocean. And then we also have here your continental crust. The word continental means land. So it's a part of the earth we're in, or which is attached or connected to land. So another way to view Earth's crust is like the skin of your apple. So if you're going to remove the red part of your apple, so what you see is the next layer, which is your mantle. So therefore, this red layer or the red skin of your apple is like the crust that we are living right now. Going back to our previous picture, so we have here your ocean and your land. So your crust is considered to be the thinnest layer of the earth, and it's made up of silicon and your aluminum as well. So obviously, so your crust, so you have here your plates, so by which the continents and ocean you rest. So again, your continents are big pieces of land, such as your the Asia continent, Europe continent, your African continent, your North and South American continents. So they are big pieces of land by which they rest on the so-called plates. So crust is part of your lithosphere, and as what we've mentioned, there are two types of crust, which is your oceanic and your continental crust. The next part is a table that compares your continental crust from your oceanic crust. So basically, so they differ in the rock type. So for continental, it's granite, and for your oceanic, it's more of your basalt. However, both of them are volcanic rocks. Also, if you can see it here, so oceanic crust is thinner compared to your continental crust. And also, please take note that oceanic crust is denser than your continental crust. And as well, they differ in the composition of your elements here. So we have here iron, magnesium, calcium for oceanic crust, and then oxygen, sodium, silicon, aluminum, and potassium for your continental crust. So in other books, so you might find the word lithosphere. So actually, your lithosphere is just a combination of your rock crust and the upper layer of your mantle. So your lithosphere, or shall we say your crust and your upper mantle, is divided into separate plates. So as you can see here, so you might observe that these plates are simply like floating on top of your mantle, because under your plates, so we have here your so-called your convection. So I hope you still remember about convection. Convection is hot air or hot water moves up, cold air or cold water goes down. So that is why in your convection currents, so they are like responsible of moving your plates which are on top of them, because as the hot air goes up or the hot liquid goes up and the cold liquid goes down, so that movement will cause this plates or continents to move apart. So basically, these plates are just floating on top of a liquid. So here's like an overview of those plates that I mentioned. So we have here your Eurasian plate, you have here your Arabian plate. So all of these plates are basically floating, and they are constantly moving all the time because remember convection. So as long as there are convection that is happening beneath the plates, so they are constantly moving. So next is we have your mantle. So your mantle has different parts. So we have here your lower mantle. We also have here your convection currents, and as well as your upper mantle. So this part is your mantle. So let's try to find out more about mantle. So let me just read the information about your mantle. So it is the largest layer of the Earth, which is around 2,900 kilometers thick. So basically, so your mantle or your middle mantle is very hot, dense rock that flows like an asphalt under heavy weight. So this is where you find your convection that is responsible for your plate movement on your crust. So if you're going to compare your mantle to an apple, so this is the white part of your apple. So as we all know already about your convection currents, so just try to look at this illustration here. So you have here a candle, your glass, and then the water, and then this is your cork. So your cork here represents your continental plate, this one, okay, or your oceanic plate. This water here compares this area, and then this candle here compares your outer core and your inner core. So as this candle is providing heat to this water, so heat moves up and then cold goes down. So this movement here will cause this cork to move from its place. So that's why, so if we're going to compare here, so this movement here or this flow here will cause these plates to move as well, causing earthquakes, or if it happens in the ocean, so it can possibly cause tsunamis. We have your core. So with your core, so basically core means center. So the core that we're talking about is the center of the earth. So we have here your outer core and as well as your inner core. So let's try to find out some information about your outer core. So your outer core, please take note, it is a melt or molten liquid metal that is around 4,700 degrees Celsius, and its thickness is around 2,266 kilometer. And please take note that that molten metal is more of your nickel and iron. And then the other layer is we have your inner core. So your inner core is basically a solid core. Please take note now, for your outer it's liquid, but for your inner it's solid. So still the same composition, you have your iron and your liquid, however it is solid state. If you look at also the temperature, it's hotter than your outer core. So what other elements that we can find here? So you can find here uranium, and as well, please take note it is solid because of the pressure from the outer core, the mantle, and the crust compressing it. So that's the reason from liquid it becomes solid, because of the pressure that is pushing down towards your inner core. So again, here is like the summary of your Earth's layer. So we have the three major layers. You have your crust, your mantle, and then your core. So with your crust, so it is the thinnest layer. So if you look at it here, it's only 5 to 40 kilometers thick compared to your 2,900, 2,250, and 1,300 kilometer thickness of other layers. Now, looking at this picture, so what does or what do these two images tell you about the layers of the Earth? The first thing that you had observed was the numbers, right? So these numbers are your temperature. So as you can see here, so as you move down, so as you start from the crust, going to your inner core, the temperature is increasing. So therefore, temperature increases as the depth increases. It's not only the temperature that is increasing as the depth goes in, so it's also the density or the thickness and the pressure that you will experience as you move towards the center. So meaning, the farther you move away from the center, so there is less density and less pressure. However, if you move towards the core, then you can feel the intensity of the pressure and its density. This is just a summary. So please take note that as you go deeper, so the pressure, the density, and the temperature increased. So let me ask you this final question. So which layer of the Earth has the greatest temperature, pressure, and density? So is it the crust, is it the mantle, or the core? Okay, very good. So it is the core because as what I've said, core means the center. So as you move towards the center, so the temperature, pressure, and density increased. So let me just share this information to you. So how far have scientists drilled into the Earth? So basically it's only 7.6 miles, or which is only about 0.2% of the distance to the Earth's core. So M2, this is your homework. So I want you to label the different layers of the Earth. So there are about 7 layers or 7 letters that you have to complete. So once you're done, so you can upload it to your Google Classroom or in our line group. So this is the end of the video about the structure of the Earth. So once again, thank you very much for watching and have a nice day, MT. Goodbye.